So welcome to my interpreted dance version of building a modern security team. Go through it like that. Hi, I'm Zane Lackey. So this talk's all, the spoiler alert of this is all really focused on what I've been working on for the past 3 years or so, which was building out the different security teams at AppSec. And it's really, the way I wanted to structure this talk was, if I could have sat myself down on day one and saved myself a bunch of pain of like lessons I had to learn and things like that, that's really what I'm trying to capture in this talk. And recently, I guess not that recent anymore, left Etsy to go co-found a company called Signal Sciences. That's totally unrelated to this. So like I said, this is really the collection of lessons I've learned about building and scaling a team, and really not so much from the management side there as the how do we adapt a security team to the way that technology development and deployment is actually changing. So I think that looking at it kind of from the other side there, how is technology changing and how are organizations changing around this? It really kind of boils down to three things in my mind. The first is that code deployment is going from a very long, drawn-out process to now essentially instantaneous. The other piece there is that we're really seeing a merging. This is me trying to dance around saying DevOps in a slide right there. So the merging of development and operations means more people with access to prod, right? Really, it means more people with more access on that. And then finally, both from the defensive and from the offensive side, think about things in terms of the cost of attack has really gone to, in a lot of cases, has really gone to zero and has really dropped across the board. So from the defensive side and from building security organizations and the way in which you approach security, these three things really are changing your world, right? And this is kind of the agenda for the talk here as well, is talking around kind of in an AppSec side of things, how do you look at AppSec in a way where not only can everyone really deploy to production, but they can do so essentially instantaneously. And then from the operations and kind of from the NetSec side of things, as we're changing, it's no longer just the ops group that has the ability to log into production or can hit production. Now you're probably any sort of startup on like a flat network where everyone can, like the CFO's laptop can SSH to prod. Maybe they don't have that shared key, but they probably do it for some way. So the first section, when I'm talking about like near instantaneous deployment, what do I mean? So I've included a highly technical chart of how we would deploy code in a waterfall model. And this is an accurate simulation where developers would choose a number of grandfather clocks and put it in their wagon as their code. They would then start down the trail, and at certain points you would have to ford the QA river, or go hunt for bugs or things like that, and then feed it back into staging, and maybe you would survive and get there. Really, any excuse I can use to put an Oregon Trail reference in the slide deck. It's kind of reaching. So what is this shifting to? So I'm going to give a bunch of details on Etsy here, but really that's just because that's the environment that I knew best on that. Really, you can replace in the next several slides here, you can replace Etsy with Facebook, with SoundCloud, with Twitter, and Square, any of these sort of companies. This is really a much larger idea than me just calling out Etsy specifically here. And that's really that you go from these sort of deploys that, for how many people have worked or currently work in some sort of waterfall model where it's, let's say, weeks or maybe months to production? All right, yeah. How many have had where it's more than 6 months to deploy to? Yeah, okay. Drink. Just, you already do, if you've been in that long. So what this is shifting to is you're watching this cycle go from years to months to weeks to days to hours, and now down to minutes, right? That I think that the fundamental shift here is two things. One, there's the speed, but it's the way in which that speed was picked up. And the way that speed was picked up was that code didn't go from one group to another group to another group, and every group would sign off and then kind of feed back into all this. If you write some code, you then push to prod. You are your QA department, you are your security department, you are your performance team, you are all of this sort of stuff, and you own that code deployment to production. And when it lives in, David summed this up really well yesterday, which was that you own your code in prod, right? So that's kind of the shift there. The way in which that you then end up doing this in practice is you constantly do your iteration, like those iteration points that you would have done previously as part of QA or staging or something like that, you now do that in production. And the ways in which you do that are really kind of three things. And everyone, Feature flags and ramp-ups, people call those different things. A/B testing, pretty much everyone calls A/B testing. But feature flags are, think like a feature flag or a config flag. Think of that as just a big if statement around a block of code. And it basically says, if this is enabled, then go ahead and execute this code. And so what you do, let's say you're starting to develop a feature, and rather than, and that feature is going to take you 2 months to develop, rather than taking 2 months and then shipping it to prod, what you do is you write a config flag for it, you start to develop some of it, and you have a very basic form of it, you then push that out into production with that flag turned off. And you say, okay, this is off, let me deploy it to production. Okay, nothing blew up, obviously, or you would hope, obviously. Okay, great. Now what I can start to do is start to define various attributes of that and say, okay, instead of it's not just off or on, it's on for these 2 predefined users. Or, okay, great, I've tested that now as like this dev team or those 2 whitelisted users. Now I'm going to flag it on for all internal employees. So any employee starts to hit that. And the goal of this is really kind of the next thing, that ramp up there. So what you can do is say, okay, I'm going to turn this on for 1% of our traffic. Okay, great, things are looking good, I can start to ramp up, and let's say I hit 20%, and at 20% I run into some incredible corner case bug, I can now flag that off and go back and fix it. Or I get up to 50%, and now I start to see like really weird performance stuff at that sort of scale, all of that. This and A/B testing, depending on which one's going on, or where, let's say you land on a site and suddenly you see a totally different feature than your friend sees over there. This is what's going on. Either they're in the middle of a ramp up, or they're in the middle of an A/B test. And so an A/B test is just essentially you can have n versions, but let's say you just put version A and version B out there, and you want to see which one does better. So if you're an e-commerce site, does version A or version B, do people buy more items because of that? Or do they favorite more things, or do they send more messages, or whatever? And then you let that experiment run for a while, and then you see. And then you go back and ideally you then make changes off of that. But the interesting thing and the takeaway really from the security perspective on this is that this is all in prod, right? So even though that there may be some feature that's out there and it's, all of that testing is now done in prod. Now some of it may only be on for a little bit of users, but sometimes all you need to do is just add some flag in the URL and you can get to totally different parts of feature code that's really not production ready yet in a sense. So this is my face on day one of landing in an environment like this, which is that coming from kind of the security background of, I think historically we've always thought of security in terms of like control and like kind of that sense of, okay, sign off and all of that, like the systems that we built around that really, they kind of make sense at the time of like, okay, well yeah, you're gonna go to the security view and then they're gonna say it's safe and all of that, and the world has changed on that. And just like any sort of world-changing thing like that, it really feels scary at first, right? That like all this code's going to be in prod, and you're never even going to see it really until it's in prod for a lot of the cases. And I think the reality of it is that this system isn't dangerous, it's actually the opposite. So now I stand up here and dispense the Kool-Aid about this because I finally like drank so much of the Kool-Aid. And the reason for that is the fundamental thing that I had to realize, which took me embarrassingly long to realize, is that it doesn't matter which of those development methodologies you have, vulnerabilities occur in all of them. Right? There hasn't been a software development methodology, a practical software development methodology that doesn't result in vulnerabilities. Right? And so that whole thought that like, oh, security needs to go sign off on all this, well, we still ship code that has bugs in it all the time. Right? And so the thing that actually, what I think is much more powerful for us here, is that our mean time to reaction is going from weeks to days to hours to minutes here. Just the same way that our deployment time has really gone like that. So the thing is that for all of us who have spent time in like waterfall methodologies and all of that, where what you go ship to prod after 8 months, and of course what happens, everything breaks, and you're like down for 48 hours or something like that, and everyone's running around, like trying to figure out what went wrong there. Same thing with the security, right? Like some SQLi comes in, or some remote code exec comes in that, and it's not part of the scheduled release process, so everybody freaks out, right? Because it's like, well, we only know how to deploy code every 6 months. Like we don't know that's supposed to be in 4 weeks. Like today's Tuesday, we can't do that. And people generally just like, you don't institutionally know how to really ship emergency patches like that. And I think that that's one of the big keys in the way that we've shifted here, that deploying, when you need to fix something, it's just another deploy to prod. You're already doing 30 today anyway. Like you've got some issue that's come in, something that you need to adapt to, you just do it. This one I loved while I was still at MC there, of notice the former vendor Etsy, and I think that quote just so perfectly illustrated that kind of old methodology of you just don't know how to get issues fixed and out the door there, and you don't know how to ship quickly on that. The context that's missing here that makes this really hilarious, it's not like, oh, that wasn't an architectural change, that was a cross-site scripting in the search box. And they're like, yeah, we will, like their CTO got on the thread and was like, we understand how serious this is for you guys, we will rush an emergency fix in 6 weeks for that. Cool, we will rush re-signing that contract. So what makes it safe? The nice thing is, what makes continuous deployment safe from a security side is what makes it safe from a reliability side, from an operations side, from a performance side, all of this sort of stuff. What makes it safe is visibility and instrumentation, right? So that here, what you're seeing here are graphs for all different parts of the stack and all different feature sets even around that. So you have like the money graph up here. When that one goes to 0, people are not happy. You have things around like deployments and errors and stuff like that on the site. So you have ones that you expect to be high all the time, right? Like checkouts or whatever your kind of core flows are, you expect those to be happening all the time. And if those go to 0, things are bad. Versus the ones you expect to be 0 all the time, which would be like core dumps. And when those go above 0, you're having a bad time as well. Right, so I think that there's a really strong parallel to, sorry for kind of the washed out stuff here, but I think there's a lot of parallels to the different instruments in aviation, in a cockpit here, right? Like, you can take off the plane without any of this sort of instrumentation, and you can be flying through the air. It's just, without that, your landings get a bit Malaysia Airlines-y, right? Right, so it's the same way that you can deploy code to production, right? Without any of this, you can deploy code to prod. It's just you don't know if the site's down without somebody writing in saying, hey, the site's not working, right? And when all of these go to 0, that's like, if your detection mechanisms there are just other people, or you're refreshing the site and it's not working, like this is what makes it safe, is that you have that sort of insight. So the great thing is applying this to security is really what makes it safe here as well. The big lesson we had to learn out of this is not just building this for your own, like your couple AppSec folks, or even just a larger security team or anything like this. This is the info that you want to surface to as much of the organization as you possibly can. So what we do, the keys out of this is put Grumpy Cat on it, and go real Michael Bay and get some lens flares and all of that too. Maybe some explosions in the background, all of that. The key is not even so much this graph or this page, it's where the TV that this was on was in the organization. This wasn't on a monitor on like a security desk facing inward to the team. This is on a TV facing out into the large part of the engineering organization. Because there isn't an engineering team on the planet that doesn't like graphs and isn't interested in graphs. And more importantly, and this was like such a subtle but fundamental change that we saw, was that when people would walk by and they would say, this one's kind of a bad example of the spike because it's so narrow, but when you would see like a crazy spike go orders of magnitude above everything else, you would get people stopping and going like, hey, what's going on? Is that like, is site down? Like, is something bad going on there? You're like, oh, that's people looking for SQL injection, orders of magnitude more than we've ever seen. And you watch that shift happen because it goes from security being an abstract concept to something that you can start to actually see. It's actually a concrete one. Right? You watch that as different development leads different engineers walk by and have that conversation, and you're like, oh, okay, wow, like, why would they be attacking us? And then you get to say, like, welcome to the internet or something. Here's your story. But the point is that this goes from you're not the crazy security person standing around shouting, trust me, attacks are coming, like all this sort of stuff. You're showing real data on this and you're surfacing it for the organization. I really love Nick Galbraith's quote on this, which is that most organizations end up treating security as a binary event. And what we mean by that is we're owned or we're not owned, right? And really what that ends up boiling down to is we think we're not owned, or Brian Krebs has just called us for comment about a database being basement, right? And that's basically the two worlds in which you live in as an organization. And when you start to surface this sort of stuff, you start to, everyone in this room takes this for granted, right? That like, we understand how attacks work, we understand how security works on this. But surfacing this to the rest of the organization saying, oh yeah, that's people trying and not succeeding, and here's the graph of people trying and succeeding, right? And it's starting to surface that as, it's not just two end states, it's everything in between. So The next section on this is around, the bullets are sold separately here, but they're totally awesome. This is around like the kind of cultural lessons that I really wish I could have told myself on day one here. The shift around, what gives us all this speed is that you function by removing blockers on this. So you're a developer, you're no longer shipping code over the wall to QA, then it's going to a different group, then it's getting to sign off by the ops group and all of that. Right? You have removed those blockers as an organization, and developers are empowered to push the prod all the time. Right? This means that if we try to do what we've been doing and kind of failing at for the last 15, 20 years of security, of being a blocker and being a sign-off gate and all this, it's like, cool, you just get routed around, right? It's like IP, right? It's like it's meant to route around damage. It feels crappy to say it, but we've been the damage in there, right? Like we are the blocker in that organization if we try to keep doing security the way that we've done it. And so what you need to focus on are a few things. Really, I think that the biggest shift, the biggest overall mindset shift for us is that how do you focus on incentivizing teams to now reach out to you? Because it's no longer that, oh, it needs all this sort of sign-off to go to prod. If somebody comes up to you and says, hey, I want to ship this feature, and like here's the details of it, and you're like, okay, well, I'm really busy, so I'll get that review done in 2 weeks, and they're like, okay, cool, yeah, you let me know. It's live now, by the way, I just deployed that, right? So like they can just go around you at any point that they want there. Obviously within, I'm exaggerating here a bit of that, but the point is that you are no longer the complete sign-off and going to prod. So I think the things to keep in mind, this one feels so dumb. There's a very strong reason why this is the very first bullet that I put up, which is that the failure modes of being a jerk you don't even really realize them. They're so bad that you don't even realize them, which is that the moment that some team comes to you and asks, hey, do you mind reviewing this code? Or hey, can you look at this? Or hey, I heard there were some bugs or something, and you're a jerk to them, you not only lose them, but you lose the rest of their team and the rest of their peers that they talk to. Right? When the condition becomes, oh, if you talk to security, they're going to make fun of you because of some vulnerability that you had, or be like, God, I can't believe you wrote this, like this is the worst code I've ever seen, anything like that. I mean, sure, you may be thinking part of that, but you don't say that. Really, like defining empathy as the core value of your team's culture is the way that this works. And the scary thing of building a team on all of this is you only need to screw it up once or maybe twice to lose it, right? So the one or two bad hires, the one or two sort of things where you make fun of someone in your own like security IRC channel, and then it turns out the developer was actually in the room on that IRC channel. You forgot to do a names before you did that, right? The little things like that, that's how you lose at it, and the worst part is you don't know that you lost because they just never come back. So the ways in which you then start to really build that trust and to actually start to get people coming to you in the first place is, I love Alex Stamos' comments around like security nihilism, right? Security is very much full of security nihilists who like, if it's not 100% perfect, it's totally wrong and we should never do anything with it, right? And in the same way where then you take a stack of vulnerabilities in some code and you're like, it has all these vulnerabilities, fix them all before you ship. And reality just doesn't work that way. Right? Being able to make realistic trade-offs is one of the most important keys you can have in, not just in AppSec, like in any part of security here really, which is that being able to take a look at that data and say, okay, here are the ones that really matter. Right? Going to a team and saying, okay, we've got 10 vulns in there from some pen test that we did or anything like that. Here's 10 vulns in your code. Here's the two that like, seriously, you gotta fix these two before they go live because here's why. And that gets into the next bullet, but here are the two that you really gotta fix. Here are the 5 that they're important to fix, but if you can promise me you'll get to them in the first week that it's out, that works for me. Maybe it's like the actual exploitation of them is really difficult, or it's in a, there's some sort of mitigation is too strong a word, but some reason why you're willing to make trade-offs on that. And then the other ones where you're like, cool, these ones really don't matter, like they're much more a best practice sort of thing. If you can get to those when you get to those, like that's comfortable enough for me. And then that's what you start to build trust on that because you're not saying all 10 have to be fixed. When you're saying something has to be fixed, it really does have to be fixed. And the flip side of that I alluded to there is being able to coherently explain it. I hate the security jargon of when you go and go, okay, well that's an input validation issue. And be like, yeah, cool, like I don't make up words to you, like why are you doing that? Being able to go and say, like, here's what this, okay, that may be the type of issue, but here's why it matters. Here's what attackers can get out of it, and here's how they can do it. right? And being able to explain that, that's how you get that buy-in for those first two. Of saying like, here's why these two are way worse than anything else. Here's how easy it is to exploit them, and here's what they get when they do. And then the random culture stuff. Like I love the team T-shirts that you guys did and the cards that you did. It doesn't really matter what. Make something to reward good behavior. Like all of this is around changing behavior, right? Reward the behavior that you want. You can't just go with security. We've always focused on like punishing the negative behavior, and it's ridiculous, right? You can't like, oh, maybe we should fire someone if they wrote too much bad code. Like you have bad days too. Figuring out what you want to do to incentivize good stuff, and it's really like what we did is we made security team T-shirts, and we only gave those out to people who had done cool stuff. So whether that was somebody who was like, hey, I found this bug in my code, do you mind taking a look at it? Or, hey, I'm designing this feature, and I know I should probably like do some encryption or something. Can we talk about it? Like, yes, we can. I assure you I have no higher priority right now. Right? Rewarding that sort of stuff, because it's actually the flip of don't be a jerk, which is where when you are a jerk, you lose that team. Like you lose all of their peers, you don't just lose them. When you reward good behavior, you get all of their team, not just them. When they go back with the first day that they get a security shirt and they wear it the next day, and the rest of their development group is like, whoa, how'd you get that? I'm like, oh, I talked to the security team. You get 5 more people showing up the next day. It's really awesome. I mean, it's shocking how well it works. This is probably the most controversial one in a sense, especially depending on your scale. But this is one I really firmly believe in, which is that historically we've had this whole approach of like, okay, I'm gonna go make up some tool name. I'm gonna go run some tool, I'm gonna get a 10,000 page report that comes out of it, and then I'm going to promptly hit the forward button to that development leader and say, your problem now, right? And their entirely rational response is, if from the security team has attachment, filter to spam. Right? Because that's essentially what you're sending them. You're like, okay, great, maybe the first time you sent that and they started actually working through on that, and the first 5 things of 10,000 were false positives, they're rationally not going to talk to you again on that. This is where taking the hit yourself as a team builds that kind of culture of trust, in that you only go to teams when you have real issues, and even more importantly on that, take the first stab at fixing them if you possibly can. So it's like, oh, this is cross-site scripting here, we don't really know the exact context in which why you made these choices here. So here's a pull request that probably, like, it fixes the issue, but we don't really understand the context of what you're doing. So you can kind of use this as a reference, but you should probably write something better than this, but here's our attempt at it, right? And it very clearly shows you're not just being like, oh, there's a problem, your problem now, right? Like you're actually trying to work with them on this. And then the way that you scale, the way that we had to learn to scale on this was via your different team leads. So team lead doesn't even have to be the manager of that team. And it doesn't even have to be the technical lead of that team. It may be just the junior or mid engineer in that team who's the most vocal. It's whoever's kind of the vocal point of that team, and those are the ones you want to build relationships with. And this is where you definitely go dispense pizza and beer and anything like that in rampant bribery of different team leads here. Thoroughly support that with as much beer as possible, or whiskey, whatever. This is where you're trying to build that relationship. The reason for that is because it doesn't matter how many trainings you run or anything like that. The rest of the organization is hiring faster than the security team is. And is already way, way bigger than the security team is. So the problem is, even when you go around and you get buy-in from different teams, by the time you go back to that team, they probably hired more engineers. And the thing is that more engineers are probably coming from a place where security was a really terrible experience, and they're going to do everything that they can to avoid you. And the thing is that when some junior engineer joins the team, the seniority level doesn't matter, a senior engineer joining the team there. And the first time they go to deploy something to prod, and whoever their team lead is says, oh cool, what security have to say about it? I'm like, why would you talk to them? I'm like, no, you actually do here. Go talk to them, they're not going to block your deployment, they're going to follow these other things. That's how you scale. You never had to have that conversation with that new employee. You're getting other people to do it for you. All right, so shifting to kind of the DevOps side of things. So access control in startups, and I should really air quote startups here, really name most companies, is very simple. Everyone can, if not access, can at least hit everything. As you're growing, I mean, this is fairly obvious, right? You're gonna have pressure from different points, whether it's regulatory, compliance, you're the first security hire, you're trying to clean things up, whatever. There's pressure to start to institute this. The biggest lesson that you have to learn on this, or that we had to learn on this, is you can take away access, but don't take away capabilities. And I'll go into what I mean on that. There's a reason that people are doing what they're doing. They're not just shouting YOLO and doing it for no reason, right? They're doing it to get their job done. And so you need to figure out what that capability, so I'll give the methodology and then I'll give a very specific example. So the methodology is figure out what the capability is that you're freaking out about as a security person and what they're trying to do to get their jobs done. Go build, this is the hard step. This is by far it might be, this takes 2 minutes and this takes 8 months, but that's how it is. Go build out the alternate, the safe way to do what you're trying to do. Then you transition the organization over, and then you alert or shut off access to, or whatever you want to do on the old unsafe way. The key lesson learned here is not figure out what the capability is, and then ban the unsafe. You don't do number 1 and then number 3 here, and just ban things right away, or number 4. Because the problem is people need that to get their job done. If you say, oh, okay, well, I'm terrified that every engineer or anyone who was even once an engineer in this place knows the shared password to the root account on every production system. Yes, that does terrify you for a reason. The difference is the key is not to then go change that password 5 minutes in and then say, okay, well, everyone come talk to me for the new one on that. Maybe if you're in the middle of an incident, that's the right thing. But the reality is, okay, let's go build out so that people have individual keys that we can revoke, that we can manage, that we can rotate, all of that. Transition people over to that and then shut off that other one. Because people need this to get their jobs done. And you want to talk about a way to instantly destroy your credibility in an organization as a security person, go take away somebody's ability to do their job, and there you go, magic. So one example that I kind of harped on there is SSH access to prod. The first step is figuring out why people do it. And so a really common one, there's a bunch of common ones, but I'd say the most common one I've heard from organizations I've been a part of and talking to other organizations there is really, you needed to go debug something, right? You had some customer support email come in or something like that saying this is broken, you can't repro it on your own dev environment, you need to go see what the error was, and so the quickest way is probably just to log into that production system and go look at the error log and go try to reproduce it through there. So the alternate approach is central logging, right? What's the thing that they actually need? They need the error log. They don't need a shell on a production web. They need that data. So going and building that out, whether it's Splunk or Elasticsearch or whatever, publicizing that to the organization, saying, hey, you need, to get your job done for this, you need these error logs, cool, here's how you do it. And it's probably even simpler now, right? You've got some GUI to do it and all of that. Now what you can do, and this is where I should have broken this down into multiple steps, but the most effective one that I saw in this is, once you get that transition point, you break this down into actually a few points, which is, step 1 is kind of soft failure, right? Alerting. So, okay, somebody just logged into prod, this should now be anomalous enough that can generate an alert. Okay, and start with that by non-sysops at first, because you expect your sysops to still log in and all of that. Then maybe the next step is, okay, shut off access to anyone who's not sysops, after that's really gone down. Because that alerting, you can say, okay, well, this person is doing it 3 times a day now for this entire week, they probably missed this entire step. Let me circle back and do that. So, soft fail, and then eventually get to your end state, which is that people can't SSH the prod, what the actual goal was. And the key here is you took away access like you wanted, but you didn't take away capability. So, final section of the talk. And it's embarrassingly late in the talk to get to a corgi photo, so I'm sorry for that. Really 2 sections. So, how are we doing? All right. 2 sections, bug bounties and then attack simulations and pen testing. So, bug bounties. So, they're super useful. And really, actually, what I should have said here is bug bounties and really just any sort of disclosure program at all are tremendously useful on this. And they can kind of be different steps, or they can just one of those can be your end state. There's a few different things. And in fact, if you're super interested in that, the talk next door is actually the one that's on bug bounties. So, if you're not working towards this though, I'd strongly consider it. It doesn't mean you're trying to ship it tomorrow. It means that you're thinking about it and you have it on your roadmap in terms of what will change between now and that day that you're working towards. So the 2 biggest concerns that I've ever heard talking to a bunch of groups out of this, because Etsy launched a bug bounty probably 2 years ago, a year and a half ago, something like that. The 2 biggest ones that we heard out there were budget concerns and then risk of attacks. So budget concerns are actually a total non-starter. This one shocked us. I mean, now it's a much more commonly known thing, but at the time it really shocked us, which is that they almost uniformly don't care about money. Now, don't get me wrong, as soon as you then say you're going to pay them, they're demanding that within like 6 minutes. But as a motivation as you're building out a bug bounty, don't think, oh, I can't get 200,000 in budget for this, so I shouldn't do it at all. If you just launch a Hall of Fame, I assure you, probably more people than you even want to will show up just for that, right? It's not, I see the nods in the room of people who have run and launched bug bounties. It is not about the money at all. In fact, the only time we had 2 where it was about the money, one was a just straight up extortion attempt. That was, they were just lying. And then the other was they didn't understand the bug that they had, so we assigned a really low payout. And they're like, what are you doing? Like, this is this bug, and you're paying me at this. And we had to just write back and be like, no, here's the bug that you actually found. Here's how you actually exploit your own bug, and here's what you actually get out of your own bug. And then they're like, oh, okay, I got it. Yeah, that's not a like world-ending thing. It's actually a super tiny thing. The risk of inviting attacks, my favorite quote on this by far is that like, it's the internet. You already get a free pen test. You just don't get the report. Right? So with a bug bounty program, you actually get the report. So the risk of inviting attacks. Now the counterpoint to this is, as you'll see in a couple slides, you are inviting things for your first window, right? Your first window of when you first launch one, and I'll get into that in a minute. But the overall risk strategically to your organization is really unchanged. The 3 goals of a bug bounty, really, I think that these are important to just kind of keep in mind as you're either building the case for it internally or just designing it yourself as you're thinking about what are we trying to get out of this. You're trying to incentivize people to report issues to you in the first place. So for those of us who have been around through the like full disclosure wars, which is every 6 months or so on BugTrack or something, but like back in the day, the problem is if you found a bug in somebody's system and you wrote in and said, hey, here's a bug, like here's how you fix it or here's how you exploit it, you probably went to jail or were threatened with going to jail. So the reason, like one of the reasons that bug bounties came out is really in the same way like full disclosure came out, is that this is meant to explicitly say, if you do this and you play by these rules, here are the rules that we are going to play by. It's like it's a safe space for everybody here, right? Like if you go find bugs in the stuff that we define here, and you report them by these, we will not sue you at all. Like you are totally covered in that case. And that's been historically, that was a super important thing. The second one here is really driving up cost of vulnerability discovery and exploitation for attackers. And the way you do that in twofold. The first is that cost of vulnerability discovery. The way in which you're doing that is by killing types of bugs as part of your bug bounty program. So you're either doing it in a few ways. Either your bounty sweeps through and they knock off a bunch of low-hanging fruit, and now it's harder and more expensive for attackers to find vulns. Or you get data from this, and I'll get into this in a minute, and you say, okay, we're actually much worse at this vulnerability type than we thought, so we need to go invest in that. Let's go clean that up, and now it's going to actually be much more difficult to find a bug. And then really exploitation. That's much more around mean time to reaction. Because the first bugs that you get coming in, like talking about patching bugs in Waterfall and all that, as your first bugs come in, it's kind of a fire drill for you. Like no matter really how prepared you are on this, it's still kind of a fire drill. Versus a bug that comes in 6 months after you launch a bounty, and you're like, yeah, cool, it's Tuesday. Like there we go, like fix it, it's all good. And so that mean time to reaction, that's what you're really expecting to go down, and you're getting better, and you're narrowing the window in which they can exploit it. And hopefully along the way, you're actually building systems to detect when they're finding vulnerabilities as well. So you're starting to shorten that time window. And then this one's so important. This is the feedback loop to what you're doing that we've been kind of missing forever. We've always thought that pen testing was providing this, and it was, but in a much narrower way than we thought. And I'll get into that in the next section. But this is the real validation of what you're doing, if it's working or not. So this one's this one's really cool. Before you launch, record what you expect to see and what you don't. Just write it down somewhere. And then see what actually happens. Right? So write down, say, I expect no remote code execution, I expect maybe a couple SQLi, no stored XSS, a few reflected, and a bunch of DOM XSS. And then 2 months later, come back and see what actually mapped up. Because when you have totally misaligned things, that's where you're like, oh, we thought we were doing something really well here. The internet disagreed. And the internet wins in that argument. So the things you want to keep metrics on are number of bugs reported and their severities, and then time to remediation of those. So around that mean time to reaction. You want those to trend down over time. You want it to be, you're hoping there's less bugs. In reality, it's probably less easily discovered bugs. And their severity, you're hoping that you're trending those down. But really, the one that you have a lot of control over is time to remediation. At first, you're going to be running around being like, who owns what? who do I talk to on this, how do we coordinate all this, you're gonna get a lot better at that real quick, or not. But you're gonna have a lot of practice at it real quick. And so you want those to trend down. I'll keep it a little high level, but let's say learn from our pain on this one. Don't just tell your security team or even your larger engineering organization this is happening. Tell everyone in the company that this is about to happen. Because when your customer support team suddenly starts getting a lot of different payloads thrown at them, you want them to know what is going on. And for example, if you maybe tell your customer support team to come running over to you if there's a little box with a 1 in it that ever shows up on their screen, and one day somebody runs over and tells you, hey, that box that you told me about is like on my laptop right now, you want to know that, I assure you. This one's cool, I'm so glad we kept 8 on this. 13 minutes. 13 minutes from time, and when I say launch, I don't mean coordinated PR, like news story launch, I mean a couple of us said something on Twitter. Yeah. So, if you want retweets ever, say you're launching a bug bounty program. Nothing gets bigger than that. We did a blog post and stuff too later, but 13 minutes. And when I say 13 minutes, I mean, this is kind of washed out. I mean stuff, if you see this a little bit, this is zoomed out to 2 months. So this to this, 13 minutes. You watch everything go off the charts. And it's going to be your first 2 to 3 weeks. Pretty uniformly. Let me say this at least, every organization I talk to has really hit that kind of 2 to 3 weeks of crazy cliff, and maybe 1 month total of just kind of increased stuff. Is that like, you were seeing the same? Yeah, I mean like, all of us that have done this have seen almost this exact stuff, which is that your first 2 to 3 weeks you're just not going to sleep and you're not going to get anything else done. If you've ever really wanted to get paged at 4 in the morning about a production web server core dumping, I strongly recommend this. But it's good. Those first 2 or 3 weeks are ripping the Band-Aid off, and you're going to be in a way better place for it. So the key out of that, the reason why I'm saying that is that plan for this. Don't plan for, hey, we're just going to kind of launch a bounty and like then get back to work. You're not. You're going to work on this for the next 2 or 3 weeks, and the things that you want to have done before that are both clearing the schedules there, which sounds like an impossible thing, but figure it out, and knowing what your team leads are for different pieces of the code base and things like that. Run this exercise. When a bug comes in this, when a remote code execution in this part of the stack comes in, who do I talk to? Run that exercise for a few different pieces of your site, and you're going to be in a way better spot. This one's deliberately vague, so I apologize, but any sort of helper systems or things things are like second order systems of internal tooling that you've done or anything like that, especially as it's around attack data. What happens when 100x the traffic hits it? Does something catch fire and fall over, or what? If you have some system that it turns out that you use for a bunch of your internal investigation stuff, and you didn't check and it's been running at 99% CPU for the last 2 weeks, and then you launch a bounty program, I guarantee that's going to fall over real quick. Like I said, and the important thing here to bring back is money's almost never the issue. It's that people want Hall of Fame credit, right? They want their name on a page. That's why they're doing this. The ones who are about money are almost always super sketchy. It's usually some sort of shakedown. These ones can get, we can have a beer afterwards if you want to hear really funny stories on these, but it's like, oh, I got root, send me 20 grand. And you're like, cool, tell me the name of the box. Like, tell me anything about our hostname structure. And I'm like, yeah, well, I hate you. We had, all right, I'll give a little side tangent here. We had one, you'll get like shakedown sort of ones where they're not even for money. They're like, well, sometimes they're for money. Like, you'll get ones where they're like, hey, I've got this remote code execution. I'm like, awesome, like, sweet, let's talk about it. And they're like, no, I want you to credit me for this, and I want you to do that. And you're like, no. And then they'll kind of write back and forth. We had this one where somebody was doing that, and they're like, I'm going to write a blog post and publish it in the next 48 hours on how to like pop root on this, and because you're not like taking me seriously. And we're like, oh, okay, like you didn't send us anything. And then they wrote back like 12 hours later, like, my mom talked me out of it. We framed that one. Your mom's right, stay in school. You'll get some special ones. There will be people's names that will make anyone burst out in tears of laughter or frustration that you can say to anyone else who's ever done a bug bounty. You'll get to be part of a very fun club on that, for certain definitions of fun. The key to interaction here is all interaction. It's all transparency. Like the thing that we had to learn on that, or that like I think the thing that's important to talk about on this, and because a lot of people have worries about this, is hey, we're actually not that fast at patching. Like we discover something, and a lot of times it takes me 2 months to get it fixed. Like, am I going to be totally screwed if I launch a bug bounty program on that? You're actually usually not. The key is to say that up front when you're talking to people and say, hey, we totally get it. We've got to take it on this. Here's the timeline that we're thinking about, and here's what we're doing with it, and we're going to like already pay you. Like we're not going to wait till it's fixed to pay you, right? And so having that update, we had one where we had to wait, I think, 4 months to fix it because we had the fix ready to go, but it was an architectural YOLO, and we were not going to do that during a certain time window, and so we had to wait. And so we just kept them in the loop on that. We're like, yeah, we said it's going to take 4 months. Every month we write them an email and say, hey, we're still on track for 3 months from now, 2 months from now, 1 month from now. Like this didn't go into a black hole. That's how you keep researchers happening. I mean, if you ever have anyone on your team who's been a researcher in the past, just ask them how they want to be treated, and this is how you do it. All right, final section. I can't see this, it's awesome. So the problems with pen test, how many people in here are or have been pen testers? You can admit it. Okay, that's the first step. So the thing is that what's funny is pen testing, right? Go grab a beer with a pen tester sometime and ask them the problems with pen testing, and we will gladly tell you, right? Because the biggest things are like scope and things like you see so much ridiculous stuff that makes the work that you're trying to do completely different from how an adversary would really react. Yeah. And so I think that this is very well understood in the offensive side. Like, I can't believe they're asking me to do this. Like, this is the thing that we should really be doing. It's not as well understood in the defensive side. The problem is that really, pen tests end up in kind of what I kind of call like vulnerability enumeration, right? At the end of the day, you get a stack of vulns in a report, and you go off and you try to fix some of those. And usually, like, you go fix the highs, and then you ignore the rest or something like that. The problem is that is incredibly useful data. I say this as having been a pen tester for 6 years. Like, this is incredibly useful data, but the problem is that this is not how attackers actually operate against your environment. Right? This is not how databases are going on pastebin. It's like that same sort of stuff. I think the problem is that from the defensive side, we've been talking about pen testing as like, okay, well, we got a pen test, and so we think that we're covering this much, and we're actually covering this much out of it. And so the way, and I'm making up a term here just because pen test is so overloaded at this point that I think that's part of the problem, that people think that they got a real pen test when they got a vulnerability enumeration or a compliance check or something like that. What I'm making up here is like attack simulations. How do attackers actually achieve goals against your organization? This complements everything else you're doing. You don't stop pen testing to do something else like this. This complements everything else you're doing, and the goal is not to show compromise as possible, because ask any pen tester or any defensive person, compromise is very, very possible. Like, it's full stop. So what you focus this on is, this is the feedback loop. In the same way that the bug bounty is the feedback loop into your AppSec program, what's working, what's not, this is the feedback loop into your NetSec program. This is where, okay, this is how my attackers are operating, this is where I can start to prioritize things and build things, right? This is where I need monitoring over here, I need detection over here, I need to shut this part off over here. This is your feedback loop. So, like I said, this complements everything. I'm going to speed it up a little bit so we have time for questions and stuff. The four biggest things we had to learn out of this were make it goal-oriented, and don't just you come up with the goals, talk to your attack team about the goals. Say, okay, here's the goals we're thinking. Obtain domain admin, grab the credit cards, read the CEO's email, whatever sort of goals like that. Ask your team for input though, because they're like, basically ask them, hey, if you're attacking an organization like us, what would you go after? Stuff will show up that you did not think about. It's really cool. This is the big one. This is like the linchpin of this entire rant, which is that there's nothing more hysterical to an attacker than the concept of scope, or a pen tester on that, right? Because it's like, oh, okay, well, you're a pen tester, you're allowed to touch over here. The internet is allowed to touch everything, and it does. So the way in which the problem is, having gone from offense to defense, you feel like, oh, that should just be an easy thing. As a defensive person, this is incredibly risky, mostly like politically, internally, and around, like, okay, well, what happens when they take down a prod BB, right? Like, something like that's the scary thing. So what we did, the way that we had to iterate on this, and the thing that we really came to is that have your attack team either call you before they do something, or if you're running these more advanced and you're actually in the dark about the details, have them call cutout. And so what you would do is, the state that you want to get to that's really fun is you set up an attack simulation going on. You know kind of the loose dates that it's going to be happening. And go read some of the, Facebook did some stuff a while ago on the red teaming stuff that Magoo published and all of that. It's really cool. Basically, you set up that the security team maybe knows that something's going to be happening, but they don't know any of the details of it. They just know something's going to be happening, or maybe not even that. And then you have, when your attack team gets to certain dangerous things, so like, to give you a specific example of this, one of the attack teams, while we were doing that, like with the security team as blinded, they got to a point where they could hit a staging database, and they had an exploit against MySQL there, but they're like, for your architecture, it lands like 90% of the time, but I know that the 10% of the time it's going to crash something will be this. So what they did is they called our cutout, and our cutout was, okay, here's what we're going to do. We're going to create some local creds on that box and give you SSH creds to it, and then proceed as if you had thrown that exploit in and landed it there, and go from that. So they don't have to do something risky to move the simulation forward and to behave as if they had landed there. Right? So we drop them on there with like MySQL cred, or not MySQL creds, MySQL user, and then they kind of. So that's how you kind of mitigate risk. And obviously, as you're starting earlier, like the security team's going to be fully in the loop, so you can be like, okay, well, we'll just allow you to move past that point now rather than doing something risky there. Go as realistic as possible. It always drives me totally nuts when you end up structuring like a network pen test as like, oh, you're allowed to touch these 3 external IPs and know anything else. And by the way, those IPs don't listen on any ports. So if you can go discover a sweet like TCP IP ODE in Linux and Windows, let us know, and here's $5,000. Right? Yeah. So the thing is, you want to start this in a way that we're actually being compromised, which is that go grab a standard build of a laptop or a desktop, put them on that. Give them remote access to that and have them start from there. You want to start getting like realistic. Tell them that build out a standard build of your laptop. Tell them that you'll have your cutout click any link that they email to it, and have them really go from there. Right? Have them click something to drop on that box, because then you get more data on methods of persistence and things like that there. If their persistence is a standard VPN connection, that's different than like, oh, they had to drop some tooling on there. If you want to simulate compromise from the web side, so like start them on a database or a web, if you're trying to simulate like a SQL injection or a remote code execution or something like that. And then just like a point on ODAs, like they're not cheating, right? I've heard that before, like, oh, well, like defenders, like, oh, well, you cheated, you like used an ODA and you couldn't detect that. Like, that's life, that's how it works. And then logistically, break this stuff down in iterations. So typically in a pen test, you end up in like, the standard one's usually like called like a 2x2, like 2 people, 2 weeks. The problem is when you then end up doing that, you basically get a report at the end. And the problem is, a lot of times as an attacker in that, you achieve your goals in like the first, 36 hours of that. And so then the problem is then you end up like kind of adding more data from there and everything. Like your pen tests aren't sitting around for those 2 weeks, but they hit their goal like early on there. What you want to do is to get the most amount of data out of this, right? Because the bug bounty side of things, you just have people going all the time. This is a lot more expensive and there's a lot more time constraints and all that. So say, okay, great. As soon as you hit your goal, start over. Now either bring in a new attack team or start for a different goal. So maybe your first goal was read CEO's email. You hit that in 12 hours, great. Now, tomorrow, I want you to go run trying to get all the credit cards, right? And so run as many of these as you can, because this is the data that you're using to start building decisions off of. What you're looking for in an output is not a stack of vulns. It's a chain from how they went from A to B to F to D to like all around you. It's why they went there. So asking people to keep notes on like, at a certain point, you were on this VLAN and you could have hit all of these things. Why did you go there versus there? And keeping notes on that is super important. Just as importantly, what they didn't do. So maybe you're like, oh, you're feeling really good about instrumentation over here, and you're like, great, we're going to detect them when they get to that point, and then they never show up, and you're like, haha, they didn't even get to that point, and then they email you a copy of your database, and you're like, ah, well, fine. Ask that question, like, you threw a great party over here, why didn't your attacker show up, right? And so maybe it's, oh, oh, well, we didn't go nmap over here or look at any sort of network enumeration because it turned out your internal wiki's unauthenticated and I just clicked in the NetOps section and then looked at your network diagram. So I knew exactly what all your stuff was. Like, I didn't need to scan for anything. Hypothetically. So what you're looking for here is as realistic of behaviors and patterns as you possibly can. You're looking for how attackers actually operate in your environment because that's your home field advantage. You know, in theory, you know your environment better than your attacker does. So what you're looking for is when they're learning your network, when they're going through, what are their behaviors and patterns? So, and you want to, the other thing you want to mix up here is both skill level and like kind of goal of, what is it, like attack profiles, right? So some of your attackers are going to be smash and grab. They don't care how noisy they are. They're going straight for the database, they're grabbing that, and they're going out the door, and they don't care if you detect them on the way. Others, their entire goal is just maintaining persistence to your network. They're not going to achieve any other objectives inside your network. It's just to maintain for when they want it later. And of, an infinity like group of things in between. And then the other thing for all those is different skill levels of each. Right? So you may have like low skill attackers who just want to maintain persistence. You may have high skill attackers who are smash and grab. Test for those different ones. Say, okay, great. I want to simulate a smash and grab. Total script kiddie, so use only off-the-shelf tools and all of that, no custom stuff, anything. Or maybe I want to simulate smash and grab with some super advanced one where for some reason they're not using anything that's off the shelf, only custom tooling, all of that. Right? So use those different profiles, and then what you're looking for is what overlaps. What's going to give you the best bang for your buck? Because, okay, even a low skill and high skill for this sort of one, well, they both went this way, so actually I'm going to start working there even though I expected to start working over here. All right, TLDR. Nope, not that corgi yet. All right, the way in which you adapt your security team to this is really surfacing security, not just for your team, but for the entire environment, for the entire enterprise. We're having to shift from being the blockers to incentivizing people to come talk to us. And when you're creating policy around this, don't take away what people need to get their jobs done. Take away access but not capabilities. And then on the flip side of how you actually bring in data into what you're doing and what's working, you want to be driving up your attacker costs and running actual examples of this with bug bounty programs, with attack simulations. Get real data on what you're doing, what's working, what's not. And thank you. Why don't we do questions up until that, and then I'll just stand up to Ryan after if you have more. That's it.
Yeah. So I'm trying to launch a bug bounty program in my company, and I've got the support of the tech org, right? Like I've got CTO, dev, ops, and product on the line. The robot is actually the security team. Yeah, so it's kind of like, we're spending a lot of money in a lot of areas, and the thought is we don't want to throw 200 grand into a program that's going to finance a bunch of cross-site scripting shit that we could have found with Burp. Mm-hmm. So do you strategically launch it with a product that's been beat to death by pen testers, or do you pick a product that has been looked at?
Okay, so the question for the camera and stuff was essentially around launching a bug bounty program. Do you, given budget constraints, do you kind of pick based on property of ones that's already been looked at or things like that? So I'd say the first part, actually, around the budget constraint, actually don't even treat that as a blocker. Like, you can launch with no money in your program at all, and just say you're Hall of Fame on that, and you're still going to get a ton, more people than you probably want will show up for just a Hall of Fame. And in fact, the way to soft launch even that is just if you don't already have a published security reports page, right? Just publish that, don't even put up a Hall of Fame, and you'll start to get people from that.
I think there's a small cost, which is just the spam that comes in.
Yes.
So not necessarily money, but it could be cost hours of people's time.
Totally agree. So to restate for everyone in the back there is cost. It's not, even though you might not have budget cost on that, you have cost on time. And that really goes to, if you go back to the slides around your first 2 to 3 weeks are going to be crazy, you're not going to ship anything on that, this is what you're going to be focused on, that's where you really pay a ton of cost. And then ongoing cost, depending on, it doesn't really matter how small you are, you're still going to get ongoing reports coming in.
Just to support Zane and the whole Hall of Fame thing, Twitter did that. dozens of emails a day, thousands of people, like people were stabbing each other to get on that page. So like, totally, that's legit. Like the whole Hall of Fame thing, you can start with Twitter did. Yeah.
Does that answer your question?
I mean, what if people don't really care about your company that much for like it's not like a Twitter, you know? I mean, I don't know.
I was at a Yarn website.
Yeah.
Much love, that's it. Yeah.
Hey, at what point did you decide the organization was like mature enough to actually do the attack simulations? Like from a point where you're like, oh, everything's wide open, everyone can access everything. Well, do I spend the money when I know how easily it will be taken down? I mean,
Yes, so good question. I went through that same thing. The question for that was, you know, how mature did you feel you had to get before you could start running like an attack simulation or anything like that? Because you feel like, hey, everything's wide open. I know it's wide open. Should I wait a couple of years to get somewhere? I would strongly argue that you should do it now. Run attack simulations now, and the reason for that is you may spend the next 2 years building a lot of stuff out, and it turns out you might have built stuff in the wrong spot, right? And so this is the date. It's like you're going to go off on something where you're kind of making a decision where it turns out without, you know, we have good feelings on this. You're like, okay, cool, well, I know I need this, and I know I need this, I know I need this, right? We're smart people on that. The problem is that getting real data only makes your choices better. Does that answer your question? Cool. One more? Yeah, sorry.
With regards to bug bounties, I've heard arguments from the more entrenched side, such as finance, healthcare, insurance, what have you, that the main justification for why they don't do it is because the potential rewards from doing the act without going after the bug bounty is more significant than, for instance, the Hall of Fame recognition and what have you.
Yeah, okay, so 2 responses to that. The first is that, like, okay, well, if someone's going to black hat you anyway, like, they don't care that you have a bug bounty, like, they're going to black hat you anyway. And the other is that I think that they operate under a couple things that, as a tech company, you just get to gloss right over, right, which is around regulation and around like, different regulatory stuff and compliance stuff. Like, you probably have, in a financial company, more lawyers than a tech company has engineers. So like, trying to get that through is its own thing. I think that they have a lot of challenges on that. I kind of reject the black hat like sort of one, but I reject that in a very specific window, which is that like people who are going to do that are going to do that anyway. Now you have to convince the lawyers that, which is a real problem for security teams of any of those organizations. All right, I'll just go right outside here if you guys